All right, more study guide. Whoop. Make that so it's not upside down. Oh my goodness. Okay. All right, so we're on number 8. A 200 kilogram object was lifted with a crane and had 18,000 joules of potential energy. How high off the ground was it lifted? Okay, so I have a mass value, I have a potential energy value, and I want to know how high. So I'm looking for height. So I'm going to use potential energy equals m times g times h, and I'm going to solve that for height. Okay, so you can put numbers in if that's easier for you, or you can turn this into an expression solved for height. I'm going to do that. So in order to solve this for height, I would divide both sides by m times g. So I end up with potential energy divided by m times g equals height. So I can solve for height that way. So height is 18,000 joules, that's my potential energy, divided by 200 times 9.8, because that's m times g. And that's going to give me, hang on, I covered my calculator up. Ooh, okay. Let's see, that's going to give me 18,000 divided by 200 times 9.8. Remember, you gotta, if you're, I'm doing this all together in my calculator, you gotta use parentheses, so just be careful with that. 9.2 meters. That's going to come out in meters. So that's how high the object was lifted. Okay. Okay, a 5 kilogram object was dropped from a height of 25 meters. A 50 kilogram object was dropped from a height of 2.5 meters. Which one has more potential energy? Well, we'll do the potential energy for both of them. So I've got my 5 kilogram object dropped from 25 meters, and then I've got to multiply that by 9.8. So that's my first object. I'll put a 1 there. And then my second object has 50 kilograms, but a lesser height. And I feel like I might know the answer to this, but we'll calculate them. So the first object is 5 times 25 times 9.8, 1,225 joules. And then my second object is 50 times 2.5 times 9.8. Yep, that's what I thought. I thought they would be the same. So, oops. So this one has a much smaller mass, but a much larger height. This one has a much larger mass and a much smaller height. They're actually going to give you the same number, just to, this one is, they're a magnitude off from each other, but it comes out to be the same in each direction. Like there's a magnitude of difference here and then here, but they're the same because this one gets bigger, this one gets smaller, if that makes sense. Maybe that makes sense, I don't know. They end up with the same potential energy. So potential energy depends on height, and it also depends on mass. And it depends on G, like if you're not on Earth, as we saw earlier. Okay. Roller coaster rolls over the top of a 30-meter tall hill, and it's going 15 meters per second as it does that. It has a mass of 1,400 kilograms. So what's the potential energy at point A? That's mass times G times H. So 1,400 times 9.8. And this is a 30-meter tall hill. So that's 1,400 times 9.8 times 30 is 411,600 joules. That's a lot. But this is a large mass, and that's 30 meters is pretty tall. So what is his kinetic energy at point A? Okay, so because in this scenario here, he's moving at the top of this hill as well. So kinetic energy, he has 1/2 times m times v squared. That's 1/2 times 1,400 times 15 meters per second, and I have to square that. Okay, so I'm going to have 0.5 times 1400 times 15 squared gives me another big number, 157,500 joules. So what's my total energy at point A? Okay, so I got to add these two up to get my total energy, or my mechanical energy is going to be PE plus KE. So I add 411,600 plus 157,500 gives me 569,100 joules. 569,100 joules. Blammo. Okay. And then what would the velocity be at point B? Okay, so this one's going to be a little trickier because now at point B we're at 15 meters. This is my halfway point. Okay. In order to get velocity here, there's kind of several steps I'll go through. Okay. The first step is to get the PE at that point. MGH is going to be 1400 times 9.8 times 15 for my height. Okay. So that's going to give me 1400 times 9.8 times 15. 205,800 joules, and that's half of what it was at the top. Like, I could have just divided by 2 at this halfway point. This number is half of this number. Okay. So I know my total energy. I know my potential energy at this point, so I can get my kinetic energy by taking ME minus PE equals KE. So my total energy is 569,100. My potential energy at this point, I said, was 205,800. So that means I've got 363,300 joules of kinetic energy at this point. Okay. And then I need to solve for velocity. So let's see, I'm going to move over here. I have kinetic energy equals 1/2 mv squared. So again, here you can put numbers in if that's easier, or you can solve this for velocity, which I did in class for us. If we solve this for velocity, we divide both sides by 1/2 m, and then we've got to take a square root. We end up with 2 times kinetic energy divided by m. We take the square root of that. That'll give us the velocity. So I've got 2 times, that's a big number, 363,300 divided by 1,400. Let's take the square root of all that. 363,300 divided by 1,400. 519, so I'm going to take the square root of 519. So that gives me 22.8 meters per second as my velocity at that point. And that should make sense. Okay, so think about at this top point, we're moving at 15 meters per second. We've got a lot of height here. Okay, now we're at the halfway point. So part of our potential energy has converted into kinetic. And so now we've got more kinetic at this point. We're going faster than we were at this point. We have less height here than we did at this point. Okay. This one's a little different because we're not starting at rest at the top. We're actually starting with the velocity at the top. So we've got some of each type of energy there, and we have some of each type here as well. Okay. Okay, I think that's almost 10 minutes. So let me stop there, and I'll try and get through the remainder of this in a final video.